Our electrostatics section, they give you with number 3, they give you this picture, and they say that Q3, 1 and 2 is in that triangle, and we have angles and we have distances, and then they say that Q3 has a resultant electrostatic force to the west. Okay, and they want to know what's the charges of Q1, 2 and 3. Okay, so this is our setup. We have Q3, 1 and 2 distances, and then they say that the resultant force that Q3 experiences is to the west. Okay, if we have Q1 and Q2 over here. All right, so that means that if we need to have a resultant force to the west, that Q3 will experience a resultant force going exactly up to there, okay, because of Q2, so it's a repulsion. And that Q3 will have a force going down here because of Q1, okay. And how did we get that resultant force again? So we drew our parallelogram, and then we got our resultant force to be there. So how did we get Q1 or Q3 and Q2 to have a force going up like that? That meant that Q3 and Q2 had to have similar charges because we had a repulsion. And that meant that Q3 and Q1 had to have opposite charges because that was an attraction. Okay? So how did we figure that out? We said that if okay, then you just have to go through the options. So we need to have Q3 and 2 to have the same things or the same charges. So Q1 and Q2 to be the same. You'll see that option D is not that. Options C, all of them is negative, so then we would have had a different thing. So Q3 can be positive as well as Q2, both of them positive to have that repulsion. That means that Q1 should be negative because we need that attraction over there. So our correct option will be then option A in that little table. 5, they say that we have the electrical field E at point M to be X, or X distance away. They want to know how does the electrical field strength, which is E, change when we have what is the correct magnitude of electrical field strength when we compare the charge with the distance of N, okay, which is twice the distance that it was with M. So we have our electrical field strength E equals KQ over R squared, and we should know from that that E is inversely proportional to R squared. So if R squared increased by 2, which we can see comparing M and N's distances, x to 2x, then our E will increase or decrease. Now it will decrease because of the inverse proportionality. It will decrease, but by how much? Not by 2, remember 2 squared. So 4 times. So that means that E will change, thus E will change to a quarter of the original E that was there. So this was E. For N it will be a quarter of E. So your correct option again is C. Right. Okay, question 37. They give you R and S, and R has a +4 and S has a 0, so it's neutral, meaning it has equal protons and electrons, okay? And then they are brought into contact, so they're touching, they touch, and then they just want to know what is the correct combination of R and S after they are then not in contact anymore, okay? So this is a normal grade 10 calculation that we said Q touch is then we have a +4 and a +0, and we have 2 charges. So both of them as a +2, let's say coulomb, okay, because it's a charge each, okay. So both of them, after they touched, the charge is then spread between the two charges, so both of them will be positive afterwards, and that will give you option B to be your correct option, that says that the charge on R is positive and the charge on S is positive as well.